Geometry. We are moving on. We are still in Unit 6 on Lesson 5. We're now going to talk about squares and circles. If you remember, our unit right now is geometry in the coordinate plane. You should have received all your packets in the mail by now. I'm sorry I couldn't put any virtual hugs in there, but I do miss you guys terribly. So let's just get started. So this says distribute each expression mentally. I'm going to give you a second. The first two you should be able to do without too much struggle. And then the next two we're going to not just do mentally, we're going to do all together. So I'm going to be quiet for about 15 seconds so you can think through those first two and maybe write them down. Okay, that might have been 15 seconds. It may have been 5 seconds. I'm not very good at wait time. I know that. If I distribute, all I'm doing is that, right? I multiply through. 5x plus 15. Here, I'm distributing through. X squared minus 3x. I know it said mentally, but now with this next one, what we're really doing is distributing like that. So I would have x squared plus 2x, and then like this. Then I would have 4x plus 8. Collect like terms. That would be my answer. You may have been taught in algebra to FOIL. First, outer, inner, last. That means first times first, okay? Outer times outer, inner times inner, and last times last. It makes a funny little face, in my opinion. You may have taught to put them in sort of like a square fashion, where I would put x plus 4 up here and x plus 2 here, and then multiply rows and columns, and then collect like terms that way. I'm not sure how you were taught. I don't really care how you do problems like that. I just need you to know how to do them, right? All right, let's go back here. So first, outer minus 5x, inner minus 5x, and last. Collect like terms. Some of you can do this in your head now. There you go. Right? We did not go mentally, but we did do some distribution. All right, now apply the distributive property to each expression. Okay, that's what we just talked about. I'm going to work down here. I have x minus 7 and x minus 7. If I just talk through FOIL, what I'm going to do here is multiply first times first. X times x is x squared. Outer is negative 7x, inner is negative 7x. If I collect those together, I get a negative 14x. We went outer, which is negative 7x, and inner, which is negative 7x. Add those together, negative 14x. And then last, plus 49. Okay, this next one, I'm not going to do that. I'm going to write them twice and do the same thing. First times first. Outer is positive 4x, inner is positive 4x. So that's an 8x. And last, 16. Again here, first, outer is negative 10x, inner is negative 10x, that's a negative 20x, and last is positive 100. And last but not least, x squared, outer is 1x, inner is 1x, add those together, and last. Okay, so we apply the distributive property to each expression using our fancy-dancy FOIL. Now let's look at our results. Each of these expressions is called a perfect square trinomial. Trinomial means it's a 3-term polynomial. Okay, 3 terms, 1, 2, 3. Perfect square means that the first term and the last term are both perfect squares. The first term breaks into x times x. The last term breaks into -7 times -7. And the middle term is 2 times my first term times my last term, which is -14x. That works for all of these. It's quite fascinating if you ask me. Okay, first term, last term, and the middle term. 2 times x times 4. I can keep going. Just going to make the video longer. 10 times 10. Actually, it's -10 times -10 because negative times negative is a positive. And then 2 times the first times the last gives me a -20. Okay, the first term is a perfect square. The last term is a perfect square. The ones always throw us off because 1 times 1 is 1. 1 squared is 1. 1 is a perfect square. And then I do 2 times x times 1. Perfect square means the first and last terms are perfect squares. Perfect squares are any two numbers that multiply each other. Like 1 is 1 squared, 4 is 2 squared, 9 is 3 squared, etc. Perfect squares. And it's trinomial, so there's 3 terms. And I guess I need to clarify the middle term is 2 times the first times the last. Cool. Now, which of these expressions are perfect square trinomials? If you get stuck, look for the patterns in your earlier. So I'm going to look at the first term. That is x times x. The last term is 3 times 3. Actually, it's -3 times -3. And then the middle term is, I didn't leave enough space, 2 times the first term times the last term. Is it a -6? Yes, it's a -6. So this one is a perfect square trinomial. Okay, the first term is x times x. The last term is not a perfect square. 20 is not a perfect square. So that doesn't work. Next, I have x times x and 9 times 9. In the middle, 2 times x times 9. Is it a positive 18? Yes, it's a positive 18. We are good. Okay, first term is x times x. Last term is -1 times -1. I picked negative because my middle is a negative. Okay, I didn't point that out, but that's what I do every time. My middle term is negative. I make my third term negative times negative. 2 times x times -1. -2 is correct. Okay, first term is x times x. Last term is 4 times 4. Middle term is 2 times x times 4, which is 8x, which is not true. Okay, rewrite perfect square trinomials you identified as square binomials. Ooh, this is good. So A, C, and D. I'm going to look at this, and it's going to help me figure it out. Okay, it just turns into x times 3, x minus 3 times x minus 3. Okay, I'm using this beginning and this end to plug in my two binomials. I guess I could write it as a squared binomial, just like that. The next one is x squared plus 18x plus 81. I'm going to use that data and make it x plus 9, x plus 9. X plus 9 squared. And D, I'm going to use the x's and the -1s, is x minus 1 times x minus 1, or x minus 1 squared. Those are squared binomials. All right, let's see if we can apply that. So here we have the equation of a circle. Okay, it's x minus 2 quantity squared plus y plus 7 quantity squared equals 10 squared. Okay, you guys may not have seen this for quite a while. We talk about this a bit in Algebra 1. But I'm going to remind you, and I'll write it up here, x minus h plus y plus, it's minus, sorry, x minus h, y minus k equals r. So what this tells us is the center is h comma k, and the radius is r. So I can use that for A. The center is 2 comma negative 7, and the radius is the square root of 10. Oh no, it's 10 squared. So the radius is just 10. I said it was a negative 7 because if you look, my formula is y minus k. So this needs to be y minus a negative 7 because that's the same as y plus 7. So we have the center and the radius. B, apply the distributive property to the squared binomials and rearrange the equation so that one side is 0. That means I'm going to take x minus 2 quantity squared, y plus 7 quantity squared, 10 squared. So if I distribute this squared binomial, I'm really doing x minus 2, which is x squared minus 4x plus 4. Okay, the first and the first is x squared. Outer is a negative 2x. Inner is a negative 2x. I add those together, I get negative 4x. And last is negative 2 times negative 2, which is positive 4. Here I have y plus 7, y plus 7. First is y squared. Outer is positive 7y. Inner is positive 7y. I add those together, I get positive 14y. And last is 49. And that's equal to 10 squared, which is 100. So this said, rearrange the equation. So I'm going to rearrange it in order from highest degree to lowest degree. So I have x squared minus 4x. I'm going to go ahead, cross it off if I use it, plus y squared plus 14y. And then I'm going to collect everything here together. 4 plus 47 is 51. And then subtract 100 from both sides. My final answer is x squared minus 4x plus y squared plus 14y minus 49 equals 0. Sorry, I just saw a mistake. Oh no, that's positive 4. So 4 plus 47 is 51. Minus 100 is 49. We're good. I think the book is wrong. Woohoo! Unless you guys see a mistake. Okay, please tell me if you see a mistake. But that is what I have right there. All right, I need a new page for number 2. So give me a second. All right, so this equation looks different, but also represents a circle. X squared plus 6x plus 9 plus y squared minus 10y plus 25 equals 64. How can you rewrite it to find the center and the radius of the circle? So I need to take that equation and change it into some squared binomials. So the book's done a nice job of putting everything in order of what I need, where I'm going to change this first trinomial, those are all good vocabulary words, this first trinomial into squared binomials. So x times x is my first term, 3 times 3 is my third term. The middle, I'm just going to check my work. 2 times x times 3 does give me 6x. So I know my perfect square, I know my squared binomial is x plus 3 quantity squared. Okay, this is what we've been doing this lesson. So here, this next trinomial, I have y times y and 5 times 5. Actually, it's going to be a negative 5 times a negative 5. And the middle gives me 2 times y times negative 5, which is negative 10, therefore it works. So I'll have y minus 5 quantity squared. And that equals, that last constant is 64, which is the same as 8 squared. So the center, this is the same as x minus a negative 3 squared. The center is negative 3 comma 5, and the radius is 8. Okay, so we answered part A and B. All right, that's really hard high-level stuff. So if you need some more practice or you don't understand your homework, please let me know and we can do a few homework problems together. No problem, okay? Good job today.